Welcome! In this series of short videos, we will give an introduction to those who have never used PowerBasic before or even considered taking up programming. Today we will look again at user-defined type variables and how we can load and save these to files in PowerBasic programming. Today we're looking again at user-defined types within arrays. And today we're going to be saving these arrays to disk. So here we have our student data user-defined type, storing 4 elements: the forename, the surname, the age, and the balance. Once we populate an array based on this user-defined type, we're going to be saving this to a file. So we're going to create a constant to hold that file name, and we'll call that constant data file. And the file we're going to create is going to be called udt-data.txt. So in our pb main function, we have dimensioned our array for 10 elements, based on the user-defined type. Next, we're going to populate this array with some data. So we will create a function called populateArray. And here is the skeleton of our function, taking its single parameter, which is a biref pointer to the student data array, defined as the student data user-defined type. And in here we have populated the first 2 elements of our array with some sample data. At the end of our function, we're going to do an initialization of the remaining records in the array. And we're going to call a separate little function to perform that task. And that function is going to be called initializeRecords. It's taking 2 parameters. One, which is the array we're going to populate, and the second is the record number within that array we're going to start at. And for each of these records, we're going to run in a for next loop, setting the forename and surname to 0-length strings, the age to 0, and the balance to 0. So now that that array has been populated, we can now display the data to the user. And we will create a small function called displayData, passing 1 parameter, which is the array. This is a very straightforward function. We're doing a for next loop from the first row to the last row in the array, and a test on the value of the age in the record. If the age is not 0, we can assume there is some data to be printed. If the age is 0, we will skip over to the next record. And we're printing out the record number, the student's name, age, and card balance. So if we try running our application now, we will see it prints out the 2 records we have prepared, record 1 and record 2. So now that we have some data within our system, we now need to look to how to save it to disk. So we're now going to create a new function called SaveTheArrayData. So this new function takes a single parameter, which is again our array. If this returns true, then we will print array saved. If it returns false, then we will print unable to save the array. And here is the skeleton of our new function, taking its single parameter. Our first task is to test to see if the data file we are going to be saving to currently exists. If it does, we're using a kill command to delete that file. Once that is completed, we're using a try-catch block to open our file for binary access writing. And then we can quite simply save the entire array using a single put command, writing to the first byte and the contents of our data array. If that works, we're returning true to the calling function. If that does not work, we're printing an error out to the log and returning false. And our final task within the block is to close the file down. So we compile our application and run the executable. At the moment, you can see there are no data files sitting in this folder. If we run the exe, our program runs, and we now have a new text file. This is a binary file, so it's not designed to be opened in Notepad. So to prove that our file has been saved successfully, let's try reloading it. But before we reload the file, let's amend one of the values in our array. So we will amend the balance of our first record in the array, and we will then call the displayData command again to redisplay the data. So let's try running that now. So we can see here is our first record with 2095 as the balance. Our array has been saved. We have amended the balance to 999.99. So now that we've updated the value in the array, let's try reloading the data which we previously saved, which should return this balance to 2095. So we will now create a new function to load the data array. And like the save data array, this will take a single parameter, which is the name of our array. If it loads successfully, it will display array loaded. We will then redisplay the data to our user. So let's create this new function. So here is our new function taking its single parameter. We're getting the next free file handle, and we're opening our data file for binary access read. We're then using a get command to start at the first character in the file and to populate our student data array from that get command. And we're sending the number of records that we have read from the file to the records variable. And we're printing this out on our log. And if no errors have occurred, we return true to the calling function. So if we run the application now, it should reload the data and redisplay it on our console. So here are our results. We changed the value to 999.99. We have then loaded the data back up from the array, and we'll see the data in the first element. The balance is now returned to 2095. So we have successfully populated an array, saved the array using a put command, and reloaded it back from disk. So we can now load and save arrays from disk. So we've achieved taking an array of 10 elements, updating it and saving it to disk, and then reloading it back from disk to confirm all the information has been successfully reloaded. However, within your applications, there will become times when you will change the size of an array during the run of the application. So how would we handle that within this application? So what we've done here is we have redimensioned our student data array to be 20 elements. We've used the preserve command word to ensure that the existing data within the array will be preserved. We're just adding 10 more records onto the end of the array. So if we try to populate the 20th record, we can do that quite easily. So there is the code to populate the 20th record with a name, an age and a balance. So if we attempt to save this to file, it will save quite happily. So having created this additional data within our array and populating the very last record, we now want to save it to disk. However, how can we handle the running of this application the next time round? As we don't know how big the array is initially. So we're going to create a new function to save the data with a header. And we will save this to a new file. So I'm creating a new constant called datafile-with-header and giving it a new name as well, udt data-with-header.txt. And we're going to create a new function to save the array with a header embedded in it. So let's create this new function. So here is the skeleton of our new function. As before, it's taking a single parameter, which is the name of our data array. I've created a new local variable here called strHeader. We're going to use this to hold the number of rows currently in the array. We're populating this header variable by using a number of commands. The ubound command will return the number of records in our array. The format $ command will turn this into a string. And we're using the write $ command to take 5 zeros plus the number of records returned and returning the rightmost 5 characters. This gives us a zero-filled variable holding the number of rows of data. Next, as we did before, we're checking for the presence of this file, and should the file exist, we're deleting it. Next, we're going to use a try-catch block to open our file for binary access once more. However, we're going to use not one, but 2 put commands here. The first put command is going to write out the header. This starts at the first character position, the first byte in the file. the next put command is going to start after the header data. So for the put command, we're using the length of file for our file handle plus 1. So 1 character beyond the last data written to the file. And we're sending out the student data. And the rest of the function is as before. We're returning true if there are no errors, we're returning false if an error occurs, and we're printing out any errors to our log. So this would save our data with header information. So now that we've successfully saved the file with a header in place, let's now redimension the array to be smaller. So the saved file will have 20 elements. I want the internal application to have only 10. So we're going to use the redim command, this time without the preserve command, to erase all the data within our student data array and set it up for only 10 elements. So the data on disk is 20 elements. The data in memory is only 10. Now we're going to call another new function to load our data array using the headers. And should this new function return true, we can then print the array loaded with header to our console and redisplay our data to the users. So let's create the new function. So here is the skeleton of our new function taking, as before, its single parameter. We've got 3 local variables here, 1 for the file handle, 1 for the number of records returned, and 1 for the header. And we're populating the header initially as 5 spaces. So our header variable has 5 character positions. We're opening the file for binary access read. And our first command is to use the get command to populate our str header variable. As this variable has only 5 spaces, it will read in the first 5 bytes from the file. This tells us how many records are actually stored in the file. We can now redimension our array to accommodate that by using the redim command, from 1 to the value of whatever the header variable actually has, as our student data user-defined type. We can then use a second get command to get from the 6th byte onwards and to populate the student data array from that section of the file. And we can print out how many records we've actually loaded. So if we try running our application now, so we can see in our log we have 2 initial records. We have amended a balance to change it to 999.99. We have then reloaded the data from disk to return the original balance. We have then redimensioned the array to 20 records and added a new record. And we have saved that to the disk using the new header function. We then redimensioned our array to only 10 records, and that wipes out all data within the array. We then loaded our array using the array with header function, and that's given us 20 records. And we can see our first record, our second record, and the third record at record 20. So in summary, what we've achieved today is we've used an array of user-defined types. We've created a function to allow us to save the array to disk, and a function to load it back up again to the same size of array. We've created a second pair of functions to load and save. These write a header to the file when you're saving the array. This tells the function which is going to subsequently load the array how many records the array should contain, and we can then redimension the array to be of the correct size to populate. So this will give you flexibility in loading and saving arrays where you don't necessarily know the size of the array before you load. Hopefully you'll find these techniques useful in your applications, but that's it for today. Thank you for watching.